Welcome back. In this module, we are going to discuss about programming languages. Software provides the instructions that run the hardware in a computer. Software tells the computer what to do. This software refers to a set of programs that gives the direction to the computer of doing the work assigned to it. A computer program, on the other hand, is a set of instructions or statements or code executed by the computer's CPU. A program is typically composed of a main module and submodules. These modules are stored as a collection of files. Large programs can contain thousands of individual files, each for a specific purpose. Some files contain instruction while some other contains data. Although a computer's code must consist of zeros and ones, computer programmers use programming languages instead of binary. Programming languages helps the programmer to describe a program using a variation of basic English. This is called the source code. Evolution of programming languages. Programming is a way of creating a set of instructions for the computer. To develop these instructions, programmers use the well-defined programming languages to create source code, then convert these source code into object code for the computer. Machine code consisting of zeros and ones is the only language understood by the computer. But programming using ones and zeros is difficult and error-prone, and hence researchers develop more sophisticated programming languages. The programming tools are developed to make programming more easily and are used to convert the human-like instructions into strings of ones and zeros. To use any of the programming languages, the programmer has to follow some rules like providing information in certain order and structure, using special symbols, using punctuation, etc. These rules are called the syntax of the programming language. The syntax of one language is different from the other. The programming languages can be grouped in different ways. Based on history, programming languages are divided into three categories such as machine level, assembly level, and higher level. Machine and assembly languages. The fundamental of all languages is the machine language. The machine code consisting of ones and zeros is created using machine language. Each computer program written in other computer languages is translated to machine language before running that program. Each type of computer has its own machine language. As machine language is the language of the CPU, programs written in this language are executed very fast. But writing programs in machine language is very time consuming and error prone. Programs written in machine language are not portable, and the programmer need to know how each instruction affects the memory and register in the CPU. Because of these limitations, programs are rarely written in machine language nowadays. Assembly language is one level above the machine language. It uses certain predefined symbolic codes called mnemonics instead of binary codes. Remembering mnemonics is easier than remembering binary codes. So, writing programs in assembly language is easier and less time consuming compared to writing programs in machine language. Assembly language closely resembles machine language and both are considered low-level languages. Since a computer cannot understand assembly language, a program written in assembly language must be translated into an equivalent machine language program before it can be run. The translation of an assembly language program into machine language program is done by a program called assembler. It also assembles the machine codes in the primary memory of the computer and makes it ready for execution. A symbolic program written by a programmer in assembly language is called source program. After the source program has been converted into machine language by an assembler, it is referred to as an object program. Limitations of machine language and assembly languages. Writing programs is difficult and time consuming. CPU specific. not portable. Programmer need to know the inner details of the system. Higher level languages. High level languages overcome these limitations to a large extent. Higher level programming languages use familiar words rather than the detailed strings of digits that make up machine instructions. For representing computer operations, these languages use operators such as plus, minus signs, etc. By this, people can read, write and understand computer programs easily. Some of the common high-level languages are Fortran, COBOL, C, C++, Java, etc. But the programs written in high-level languages must be translated into equivalent machine language program. This is done using translation programs like compilers and interpreters. The interpreter translates the program written in a high-level language into machine language at the time of executing that program instruction by instruction. Therefore, no object code is saved for future use. While using an interpreter, the translation and execution process alternate. The compiler translates the entire high-level language program into equivalent machine language program called the object program before executing it. These object codes will be saved permanently. Hence, the programs can be executed without compiling in the future. Programming languages are sometimes referred in terms of generations. Machine languages are called first generation languages and assembly languages are called second generation languages. Third generation languages. The third generation languages help to write structured program easier. These languages use English-like phrasing and allow the sharing of programs. Even though each of the third generation languages has its own syntax, they are English-like and easy to understand. Another important advantage of third generation languages is portability. In order to port the code from one system to another, the only condition is that the new system should have a compiler or interpreter to create an executable from the source code. Since the statements in a third generation language could theoretically be created on any machine simply by applying the appropriate compiler, but in reality it is not that much simple. When a compiler is designed, particular characteristics of the underlying machine are reflected as conditions on the language being translated. This problem of portability is mainly due to the lack of standards. To aid in this regard, the American National Standards Institute and the International Organization for Standardization have adopted and published standards for many of the popular languages. Fourth generation languages. Fourth generation languages are easier to use than the third generation languages. These languages use either a text environment or a visual environment. In the text environment, English-like words are used and is similar to that of third generation languages. In a fourth generation language, visual environment or the programmer uses a toolbar to drag and drop various items like buttons, text boxes, labels, etc. to create a visual definition of an application like user interface or reports. Most third generation languages and fourth generation languages allow the programmer to work in an integrated development environment or IDE. An IDE is a programming environment which presents aids for designing, coding, editing, debugging and testing the program. Fourth generation languages also include the authoring environments for creating multimedia application, computer-based training program, web pages, etc. Fifth generation languages. The fifth generation languages are actually of a little bit confusing. Some experts consider the more advanced authoring environments to be fifth generation languages while others do not. On principle, a fifth generation language would use artificial intelligence to create software based on users' descriptions. Programming paradigms. The generation approach of classifying programming language is based on a linear scale on which a language's position is determined by the degree to which the user of the language is freed from the features of computer and allowed to think in terms of associated with the problem. The historical development of programming languages is represented in the following figure. The figure shows 4 parts representing the functional, object-oriented, imperative and declarative paradigms with different languages associated with each paradigm positioned in a manner that indicates their development relative to other languages. The imperative paradigm or the procedure paradigm represents the traditional approach to the programming process. The imperative paradigm defines the programming process to be the development of sequence of commands that, when followed, manipulate data to produce the desired result. Hence, the imperative paradigm gives the approach of programming process by finding an algorithm to solve the problem and expressing that algorithm as a sequence of commands. The declarative paradigm asks a programmer to describe the problem to be solved rather than an algorithm to be followed. That is, a declarative programming system applies a pre-established general purpose problem solving algorithm to solve problems presented to it. The other programming paradigm is called the functional paradigm, in which the program is viewed as an entity that accepts input and produces the outputs. By this paradigm, a program is constructed by connecting smaller predefined program units or predefined functions so that the output from each unit can be fed as the input to the next unit. Another programming paradigm is the object-oriented paradigm, which is associated with the programming process called object-oriented programming or OOP. Here, a software system is viewed as a collection of units called objects. These objects are capable of performing the actions that are immediately related to itself as well as requesting actions of other objects. These objects would be associated with a collection of procedures called methods describing how that object is to respond to the occurrence of various events. The system's development life cycle for programming. Programs are the fundamental units of information systems. To create software products, programmer follows a series of processes or life cycle. Phase 1, needs analysis. After the problem is identified and understood, the programmer checks the program designed to see what the user needs the program to do. Before beginning the design, the programmer has to determine the program's starting and stopping points. Phase 2, program design. In the design stage, the programmer will figure out the logic for coding. Many tools are used for designing, such as IPO charts for structured programming, circles and message pipes for object-oriented programming, and pseudocode, etc. Phase 3, development. Development or coding involves writing and testing the source code. The programmer writes codes to implement the requirements of the user. For the coding, the programmer can use a text editor or a visual editor. While coding, there are chances for errors or bugs in the program. The two main types of bugs are syntax errors and logic errors. The syntax errors occur when the rules of the programming languages are violated. The compiler or interpreter will point out these errors, and hence finding out this type of errors is relatively easy. Logic errors or the mistakes in algorithm are difficult to find out and may not even noticed before implementation. The process of identifying and eliminating these errors is called debugging. Phase 4, implementation. Implementation involves installing software and allowing users to test it by using. This step often consists of a lot of documentation both inside the code and in the form of manuals for the users. Before implementation, all the misconceptions of the programmer about the codes are found and fixed. Phase 5, maintenance. Maintenance starts as soon as the program is installed. Work continues due to several reasons. Some minor bugs may not have been fixed at the time of program release. Sometimes there may be some minor additions or sometimes major modifications in response to the user requests. This is the longest phase of the program development life cycle, which lasts for several years. Traditional programming concepts. Here we are going to have a discussion on some of the concepts found in imperative and object-oriented programming languages. C is a third generation imperative language. C++ is an object-oriented language which is an extension of C. Java and C# are object-oriented languages derived from C++. Whatever may be the basic concepts followed in each language, the statements in the programming languages tend to fall into three categories: declarative statements, imperative statements and comments. Declarative statements define customized terminology used in the program. These are the names used to reference data items. Imperative statements describe steps in the underlying algorithm. Comments are used to enhance the readability of a program. It explains the features of program in a human understandable form. Variables and data types. High-level programming languages allow the main memory locations to be referenced by descriptive names rather than numbers. Such a name is known as a variable, which implies that the value stored at each location will be changing as the program executes. The programming languages require that these variables be identified through declarative statements before being used in the program. These declarative statements require the programmer to specify the type of data that will be stored at the memory locations referenced by variables. Such a type is known as a data type and encompasses the manner in which the data item is encoded and the operations that can be performed on that data. The type integer refers to numeric data consisting of whole numbers which will be stored in 2's complement form, and the operations associated with integer data include arithmetic operations, logical operations, etc. An integer type variable to be used in a program should be declared toward the beginning of the program as int limit, which means that limit is a variable which will be used later in this program to refer to a memory area containing a value stored in 2's complement form. The real type or float refers to the numeric data other than whole numbers. These are stored in floating point notation and the operations associated with are similar to those of integers. Other common data types used are character and boolean. Character refers to the data consisting of symbols and stored in ASCII or Unicode. The operations performed on these data include the comparisons, concatenation, etc. The statement char letter could be used in C, C++, C# and Java to declare the variable letter to be of type char. The type boolean refers to data items that can take only true or false values. The operation of boolean includes inquiries as to whether the current value is true or false. The types such as int, char, float, boolean are called the primitive types. The translator uses the knowledge from the declaration statements to translate it into machine language and to signal the errors in operation. Data structure. The programs are often associated with certain data structure, which is the conceptual shape or arrangement of data. For example, text is normally viewed as a long string of characters. Students' records may be viewed as a rectangular table where each row represents the associated information about a particular student. One common data structure used in programming languages is the homogeneous array, which is a collection of values of the same type. The arrays can be one-dimensional as a list, two-dimensional as a table, or with tables of higher dimensions. To establish such an array, most of the programming languages require the declaration statements to specify the name of the array along with the length of each dimension of the array. Int marks 510 means that the variable marks will be used in the program to refer to a two-dimensional array of integers having 5 rows and 10 columns. Once a homogeneous array has been declared, it can be referenced in the program by its name, and the individual components or items can be referenced by specifying the indices that specify the row and column. For example, the statement marks 24 refers to the individual component stored in marks in the fourth column of the second row. There is also a heterogeneous array which represents a block of data in which different elements can have different types. These are referred to as structure and declared as struct open brace char name of 20 int age float grade point then close brace student, which says that variable student is referred to a structure consisting of 3 members called name, age and grade point, constants and literals. Sometimes a fixed predetermined value is used in the program. For example, the program for controlling the air traffic in a particular airport contains numerous references to that airport's altitude above the sea level. While writing a program, one can include this value, say 765 feet, literally each time it is required. Such an explicit appearance of a value is called a literal. The use of literals leads to program statements such as effective alt equal to alt plus 765, where effective alt and alt are assumed to be variables and 765 is a literal. In most programming languages, literals are delineated with quotation marks to distinguish them from other program components. Often, the use of literals masks the meaning of the statements in which they appear. Moreover, literals complicate the task of modifying the program. To solve these problems, programming languages allow descriptive names to be assigned to specific non-changeable values. Such a name is called constant. For example, const int altitude equal to 765 associates the identifier altitude with the fixed value 765. With this, the above statement can be rewritten as effective alt equal to alt plus altitude. While modifying the program, it needs only a single change to the declaration statement of the constant. Assignment statements. Once the terminologies to be used in the program have been declared, a programmer can start describing the algorithm involved. This is done by means of imperative statements. The most basic imperative statement is the assignment statement, which requests that a value be assigned to a variable. The statement sum equal to num1 plus num2 in C, C++, C# and Java requests that the sum of num1 and num2 be assigned to the variable sum. The power of assignment statements comes from the scope of expressions that can appear on the right side of the statement. Many programming languages allow the use of one symbol to represent more than one operation. In these cases, the meaning of the symbol is determined by the data type of the operands. For example, the symbol plus represents addition when used with numeric, and the same symbol when used with the character strings results in concatenation. Such multiple use of an operation symbol is called overloading. Control statements. A control statement is an imperative statement that alters the execution sequence of the program. Modern languages are designed with control statements that allow an entire branching structure to be expressed within a single statement. The commonly used control structures in high-level programming languages are if then else, while, case and for. The if then else allows a choice between two options, and a while repeats the statements if the specified condition is true. Case is a multi-way selection statement in which the selection is based on the same expression or variable. The for is a loop structure similar to while, but the difference is that the initialization, modification and the termination of loop is incorporated in a parenthetical structure within the single statement. Comments. Though the programming language is well designed, additional information is helpful when a human tries to read and understand a well-featured program. For this, the programming languages provide ways of inserting explanatory statements called comments within the program. These statements are ignored by the translator. Without such documentation, large complex programs are difficult for a programmer other than its developer to understand and modify if necessary. There are two common ways of inserting comments in a program. One is to surround the entire comment by special markers and the other at the beginning of the comment at one end. The single line comments are marked as to begin with double slashes, while the other to be surrounded by slash star and star slash. Double slash, this is a comment, and slash star, this is a comment, star slash are valid comments. A good approach to put comments is by collecting the comments that relate to a single program and put it at the beginning of the unit. This will increase the readability of the program. Let us summarize the module. In this module, we have discussed the basic features of a programming language. We covered the topics such as the history and evolution of programming languages, the fundamental building blocks of the programming language such as variables, data types, data structures, constants, literals and the control constructs. We concluded by referring to the statements such as assignment and comments. Please try to answer the following questions. Explain the evolution of the programming language. What are the different programming paradigms? Differentiate between machine level language and high level language. Write a note on machine language. What is meant by assembly language? Explain the system development life cycle for programming. What is meant by a data structure? What is the role of comments in programming? Hope you enjoyed this session. See you next time. Until then, bye.